The McDonnell Douglas DC-10 is a three-engine wide-body jet airliner manufactured by McDonnell Douglas. The DC-10 has range for medium to long-haul flights, capable of carrying a maximum of 380 passengers. Its most distinguishing feature is the two turbofan engines mounted on underwing pylons and a third engine at the base of the vertical stabilizer. The model was a successor to McDonnell Douglas's DC-8 for long-range operations, and competed in the same markets as the Lockheed L-1011 TriStar, which has a similar layout to the DC-10. Production of the DC-10 ended in 1989 with 386 delivered to airlines and 60 to the U.S. Air Force's air-to-air refueling tankers, designated KC-10 Extender. The largest operator of the DC-10 is U.S. cargo airline FedEx Express. The DC-10 was succeeded by the related McDonnell Douglas MD-11. Boeing, which merged with McDonnell Douglas in the 1990s, conducted an upgrade program that equipped many in-service DC-10s with a glass cockpit that eliminated the flight engineer position. The upgraded aircraft were redesignated as MD-10s. The DC-10's last commercial passenger flight took place in February 2014. Development: following an unsuccessful proposal for the U.S. Air Force's CXHLS in 1965, Douglas Aircraft began design studies based on its CXHLS design. In 1966, American Airlines offered a specification to manufacturers for a wide-body aircraft smaller than the Boeing 747 but capable of flying similar long-range routes from airports with shorter runways. The DC-10 became McDonnell Douglas's first commercial airliner after the merger between McDonnell Aircraft Corporation and Douglas Aircraft Company in 1967. An early DC-10 design proposal was for a four-engine double-deck wide-body jet airliner with a maximum seating capacity of 550 passengers similar in length of a DC-8. The proposal was shelved in favor of a trijet single-deck wide-body airliner with a maximum seating capacity of 399 passengers, and similar in length to the DC-8 Super 60. The DC-10 was first ordered by launch customers American Airlines with 25 orders, and United Airlines with 30 orders and 30 options in 1968. The first DC-10, a Series 10, made its maiden flight on August 29, 1970. Following a test program with 929 flights covering 1,551 hours, the DC-10 received its type certificate from the FAA on July 29, 1971. It entered commercial service with American Airlines on August 5, 1971 on a round-trip flight between Los Angeles and Chicago. United Airlines began DC-10 service on August 16, 1971. American's DC-10s had 206 seats and United's had 222. Both had 6 across seating in first class and 8 across in coach. The DC-10's similarity to the Lockheed L-1011 in design, passenger capacity, and launch date resulted in a sales competition that affected profitability of the aircraft. The first DC-10 version was the domestic Series 10 with a range of 3,800 miles with a typical passenger load and a range of 2,710 miles with maximum payload. The Series 15 had a typical load range of 4,350 miles. The Series 20 was powered by Pratt & Whitney JT9D turbofan engines, whereas the Series 10 and 30 engines were General Electric CF6. Before delivery of its aircraft, Northwest's president asked that the Series 20 aircraft be redesignated Series 40, because the aircraft was much improved over the original design. The FAA issued the Series 40 certificate on October 27, 1972. The Series 30 and 40 were the longer-range international versions. The main visible difference between the models is that the Series 10 has 3 sets of landing gear while the Series 30 and 40 have an additional centerline main gear. The center main two-wheel landing gear was added to distribute the extra weight and for additional braking. The Series 30 had a typical load range of 6,220 mi and a maximum payload range of 4,604 mi. The Series 40 had a typical load range of 5,750 miles and a maximum payload range of 4,030 miles. Eventually, The DC-10 was able to distinguish itself from its competitor with two engine options, as well as earlier introduction of longer-range variants than the L-1011. The 446th and final DC-10 rolled off the Long Beach, California Products Division in production line in December 1988 and was delivered to Nigeria Airways in July 1989. The production run exceeded the 1971 estimate of 438 deliveries needed to break even on the project. As the final DC-10s were delivered, McDonnell Douglas had started production of its successor, the MD-11. Design. The DC-10 is a low-wing cantilever monoplane, powered by three turbofan engines. Two engines are mounted on pylons that attach to the bottom of the wings, while the third engine is encased in a protective banjo-shaped structure that is mounted on the top of the rear fuselage. The vertical stabilizer, with its two-segment rudder, is mounted on top of the tail engine banjo. The horizontal stabilizer and its four-segment elevator is attached to the sides of the rear fuselage in the conventional manner. The airliner has a retractable tricycle landing gear. To enable higher gross weights, the later -30 and -40 series have an additional two-wheel main landing gear, which retracts into the center of the fuselage. It was designed for medium to long-range flights that can accommodate 250 to 380 passengers, and is operated by a cockpit flight crew of 3. The fuselage has underfloor stowage for cargo and baggage. Variants. Original variants, DC-10-10. The DC-10-10 is the initial passenger version, produced from 1970 to 1981. The DC-10-10 was equipped with GE CF6-6 engines, which was the first civil engine version the CF6 family. A total of 122 were built. DC-10-10CF. The -10 CF is a convertible passenger and cargo transport version of the -10. 8 were built for Continental Airlines and 1 for United Airlines. DC-10-15. The -15 variant was designed for use at hot and high airports. The Series 15 is basically a -10 fitted with higher thrust GE CF6-50C2F power plants. The -15 was first ordered in 1979 by Mexicana and Aroma copyright Zico. 7 were completed between 1981 and 1983. Longer range variants. DC-10-20. A proposed version of the DC-10-10 with extra fuel tanks, 3-foot extensions on each wingtip and a rear center landing gear. It was to use Pratt & Whitney JT9D15 turbofan engines, each producing 45,500 pound-force of thrust, with a maximum takeoff weight of 530,000 lb. But engine improvements led to increased thrust and increased takeoff weight. Northwest Orient Airlines, one of the launch customers for this longer-range DC-10, requested the name changed to DC-10-40. DC-10-30, a long-range model and the most common model produced. It was built with General Electric CF6-50 turbofan engines and larger fuel tanks to increase range and fuel efficiency, as well as a set of rear center landing gear to support the increased weight. It was very popular with European flag carriers. A total of 163 were built from 1972 to 1988 and delivered to 38 different customers. The model was introduced in service on November 30, 1972, with Swissair and KLM as its first customers. DC-10-30CF, the convertible cargo passenger transport version of the -30. The first deliveries were to Overseas National Airways and Trans-International Airlines in 1973. A total of 27 were built. DC-10-30ER, the extended range version of the -30. The -30ER aircraft has a higher maximum takeoff weight of 590,000 lb, is powered by 3 GE CF6-50C2B engines each producing 54,000 pound-force of thrust and is equipped with an additional fuel tank in the rear cargo hold. It has an additional 700 mi of range to 6,600 mi. The first of this variant was delivered to Finnair in 1981. A total of 6 were built and 5 -30s were later converted to -30ERs. DC-10-30AF, also known as the DC-10-30F. This was the all-freight version of the -30. Production was to start in 1979, but Alitalia did not confirm its order then. Production began in May 1984 after the first aircraft order from FedEx. A total of 10 were built. DC-10-40, the first long-range version fitted with Pratt & Whitney JT9D engines. Originally designated DC-10-20, this model was renamed DC-10-40 after a special request from Northwest Orient Airlines as the aircraft was much improved compared to its original design, with a higher MTOW and more powerful engines. The airline's president wanted to advertise he had the latest version. The company also wanted its aircraft to be equipped with the same engines as its Boeing 747s for commonality. Northwest Orient Airlines and Japan Airlines were the only airlines to order the Series 40 with 22 and 20 aircraft, respectively. Engine improvements led to the DC-10-40 delivered to Northwest featuring Pratt & Whitney JT9D-20 engines producing 50,000 pound-force of thrust and an MTOW of 555,000 lb. The -40s for Japan Airlines were equipped with P&W JT9D-59A engines that produced a thrust of 53,000 pound-force and a MTOW of 565,000 lb. 42 were built from 1973 to 1983. Externally, the DC-10-40 can be distinguished from the -30 series by a slight bulge near the front of the nacelle for the number 2 engine. DC-10-50, a proposed version with Rolls-Royce RB211-524 engines for British Airways. The order never came and the plans for the DC-10-50 were abandoned. DC-10 Twin, a proposed downsized DC-10 version with 2 CF6 engines, likely designed to compete against the Airbus A300. Tanker versions. The KC-10 Extender is a military version of the DC-10-30 CF for aerial refueling. The aircraft was ordered by the U.S. Air Force and delivered from 1981 to 1988. A total of 60 were built. The KDC-10 is an aerial refueling tanker for the Royal Netherlands Air Force. These were converted from civil airliners to a similar standard as the KC-10. Also, commercial refueling companies Omega Aerial Refueling Services and Global Air Tanker Service operate 2 KDC-10 tankers for lease. 4 have been built. The DC-10 Air Tanker is a DC-10-based firefighting tanker aircraft, using modified water tanks from Erickson Air Crane. MD-10 Upgrade. The MD-10 is retrofit cockpit upgrade to the DC-10 and a redesignation to MD-10. The upgrade included an advanced common flight deck used on the MD-11 and was launched in 1996. The new cockpit eliminated the need for the flight engineer position and allowed common type rating with the MD-11. This allows companies such as FedEx Express, which operate both the MD-10 and MD-11, to have a common pilot pool for both aircraft. The MD-10 conversion now falls under the Boeing Converted Freighter program where Boeing's international affiliate companies perform the conversions. Operators. In July 2013, there were 69 DC-10s and MD-10s in airline service with operators FedEx Express, Kelowna Flightcraft Air Charter, and others with fewer aircraft. The aging models are now largely used as dedicated freight aircraft. The DC-10 is going to be remembered as a better cargo plane than passenger plane, said Richard Abulafia, an analyst with the Teal Group. On January 8, 2007, Northwest Airlines retired its last remaining DC-10 from scheduled passenger service, thus ending the aircraft's operations with major airlines. Regarding the retirement of Northwest's DC-10 fleet, Wade Blaufus, spokesman for the Northwest chapter of the Airline Pilots Association said, "The DC-10 is a reliable airplane, fun to fly, roomy and quiet, kind of like flying an old Cadillac Fleetwood. We're sad to see an old friend go." Biman Bangladesh Airlines was the last commercial carrier to operate the DC-10 in passenger service. The airline flew the DC-10 on a regular passenger flight for the last time on February 20, 2014, from Dhaka, Bangladesh to Birmingham, UK. Local charter flights were flown in the UK until February 24, 2014. Non-airline operators include the Royal Netherlands Air Force with 3 DC-10-30 CF-based KDC-10 tanker aircraft, the USAF with its 59 KC-10s, and the 10 tanker air carrier with its modified DC-10-10 used for fighting wildfires. Orbis International has used a DC-10 as a flying eye hospital. Surgery is performed on the ground and the operating room is located between the wings for maximum stability. In 2008, Orbis chose to replace its aging DC-10-10 with a DC-10-30 jointly donated by FedEx and United Airlines. The newer DC-10 was to be converted into MD-10 configuration, and begin flying as an eye hospital in 2010. One former American Airlines DC-10-10 is operated by the Missile Defense Agency as the Widebody Airborne Sensor Platform. Incidents and accidents. As of May 2013, the DC-10 was involved in 52 aviation accidents and incidents, including 32 hull loss accidents, with 1,261 occupant fatalities. It has been involved in 9 hijackings and criminal events resulting in 171 occupant fatalities. Despite its troubled beginnings in the 1970s, which gave it an unfavorable reputation, the DC-10 has proved to be a reliable aircraft with a low accident rate. The DC-10's initially poor safety record continuously improved as design flaws were rectified and fleet hours increased. The DC-10's lifetime safety record is comparable to similar second-generation passenger jets as of 2008. Cargo door problem. The DC-10 was designed with cargo doors that opened outward instead of conventional inward-opening plug-type doors. Using outward-opening doors allowed the DC-10's cargo area to be completely filled since the door was not occupying usable space. To secure the door against the outward force from the pressurization of the fuselage at high altitudes, outward-opening doors must use heavy locking mechanisms. In the event of a door lock malfunction, there is great potential for explosive decompression. American Airlines Flight 96, a problem with the outward-opening cargo door first became publicly known on June 12, 1972, when American Airlines Flight 96 lost its aft cargo door shortly after takeoff from Detroit Metro Airport. Before Flight 96 took off, an airport employee had forced the door shut, which, due to the cargo door's design, gave an outward appearance of being securely locked despite the internal locking mechanism not being fully engaged. Subsequently, when the aircraft reached approximately 11,750 feet in altitude, the rear cargo door blew out, causing an explosive decompression that partially collapsed the cabin floor above the door. This collapsed section of the floor cut or impeded many of the control cables to the empennage control systems necessary to fly the aircraft. The crew was able to accomplish an emergency landing by using the ailerons, right elevator, some limited rudder trim and asymmetrical thrust of the wing engines. During the investigation of the near crash of Flight 96, U.S. National Transportation Safety Board investigators found that the DC-10's cargo door design was dangerously flawed. The door relied on a set of heavy steel hooks to secure it against the door frame. When the hooks were fully engaged, an outside lever on the cargo door could be depressed, which drives a set of locking pins through the hooks, holding them in place. The NTSB investigation found that it was possible to close the outside lever without the hooks being fully engaged, and there would be no outward signs that the locking mechanism was not engaged. Even though the hooks and locking pins were not in the closed position, the cargo door indicator in the cockpit would still register the door as being secured. This combination of factors caused Flight 96 to take off without its aft cargo door being fully locked. When the door blew out at altitude, the sudden decompression caused a large pressure difference to build up between the cabin above and the cargo bay below. This depressurization loading is what caused the cabin floor to collapse. Because the DC-10 was designed with its hydraulics and control wires routed through the floor beams, the collapse of the cabin floor caused a loss of vital flight controls. Following the Windsor incident investigation, the NTSB made several recommendations, including repairing the faulty cargo door design to make it impossible for baggage handlers to close the cargo door lever without the locking pins being fully engaged. It was also recommended that vents be installed in the cabin floor so that, In case of an explosive decompression, the pressure difference between the cabin and cargo bay could quickly be equalized without collapsing the cabin floor and damaging critical control systems. Although many carriers voluntarily modified the cargo doors, no airworthiness directive was issued to require reworking of the locking system, due to a gentleman's agreement between the head of the FAA and McDonnell Douglas. McDonnell Douglas did make modifications to the cargo door, but the basic design remained unchanged and problems persisted. Turkish Airlines Flight 981, on March 3, 1974, an almost identical cargo door blowout caused Turkish Airlines Flight 981 to crash into a forest near the town of Ermenonville, France shortly after leaving Paris. All 346 people were killed in one of the deadliest air crashes of all time. Circumstances of this crash were very similar to the previous accident. The cargo door had not been fully locked, though it appeared so to both cockpit crew and ground personnel. The Turkish aircraft had a different seating configuration that exacerbated the effects of decompression, which caused the aircraft's floor to collapse into the cargo bay. Control cables running below the floor of the aircraft were severed when the floor collapsed, and this rendered it uncontrollable. Crash investigators found that the DC-10's relief vents were not large enough to equalize the pressure between the passenger and cargo compartments during explosive decompression. Following this crash, a special subcommittee of the House of Representatives investigated the cargo door issue and the FAA's certification of the original design. An airworthiness directive was issued, and all DC-10s underwent mandatory door modifications. The DC-10 experienced no more major incidents related to its cargo door after FAA-approved changes were made. American Airlines Flight 191, the DC-10 experienced another major accident with the crash of American Airlines Flight 191 on May 25, 1979. The number 1 engine of Flight 191 broke off after taking off from O'Hare International Airport in Chicago, USA. As the engine separated upwards, it ripped through the leading edge of the wing, rupturing hydraulic lines. Without hydraulic pressure, the left wing leading edge slats retracted due to the force of the air moving over the wings. That, in turn, increased the stall speed of the left wing above the engine failure climb-out speed being used by the pilots. When the left wing stalled, the aircraft rapidly rolled to the left and crashed before the flight crew could recover. All 271 people on board, plus 2 on the ground, were killed. The National Transportation Safety Board officials discovered that a maintenance procedure was the cause. American Airlines mechanics removed the engine and its pylon together, rather than removing the engine from the pylon and the pylon from the wing, as recommended by McDonnell Douglas. This was done using a forklift, and the pylon was inadvertently cracked in the process. The shortcut procedure, believed to save many man-hours on maintenance, was used by 3 major airlines, although McDonnell Douglas advised against it. In November 1979, the Federal Aviation Administration fined American Airlines $500,000 for using this faulty maintenance procedure. Continental Airlines was fined $100,000 on a similar charge. The Chicago accident also highlighted a major deficiency in the DC-10 design, its lack of a locking mechanism to maintain the position of the leading edge slats in the event of a hydraulic or pneumatic failure. Other wide-body aircraft of the day carried such a feature. When the engine pulled up and over the wing, it tore out electrical wiring in the wing, thus rendering vital warning instruments in the cockpit inoperable. Following the Chicago crash, the FAA withdrew the DC-10's type certificate on June 6, 1979, which grounded U.S. DC-10s. It also banned all DC-10s from U.S. airspace. These measures were rescinded on July 13 after modifications were made to the slat actuation and position systems, along with stall warning and power supply changes. United Airlines Flight 232, another major DC-10 crash, was the United Airlines Flight 232 crash at Sioux City, Iowa, USA, on July 19, 1989. The number 2 engine suffered an uncontained fan disk failure in flight, which damaged all 3 hydraulic systems and rendered the hydraulic flight controls inoperable. The flight crew, led by Captain Al Haynes and assisted by a senior pilot flying as a passenger, performed an emergency landing by constantly adjusting the thrust of the remaining two engines. The crew managed to fly the aircraft onto the runway in a partially controlled manner, and 185 of the 296 people on board survived in spite of the destruction of the aircraft during the crash landing. The DC-10 included no cable backup for the hydraulic-powered flight controls because it was considered nearly impossible for three hydraulic systems to fail during one flight, and furthermore the control surfaces are too large to be moved without hydraulic assistance. However, all three hydraulic systems were in close proximity, directly beneath the tail engine. The number 2 engine explosion hurled fragments that ruptured all three lines, resulting in total loss of control to the elevators, ailerons, spoilers, horizontal stabilizer, rudder, flaps and slats. Following the UAL-232 accident, hydraulic fuses were installed in the number 3 hydraulic system in the area below the number 2 engine on all DC-10 aircraft to ensure that sufficient control capability remained if all three hydraulic system lines should be damaged in the tail area. It is still possible to lose all three hydraulic systems elsewhere. This nearly occurred to a cargo airliner in 2002 during takeoff, when a main gear tire exploded in the wheel well. The damage in the left wing area caused total loss of pressure in the number 1 and the number 2 hydraulic systems. The number 3 system was dented but not penetrated. Other notable accidents and incidents are, November 3, 1973, National Airlines Flight 27, a DC-10-10 cruising at 39,000 feet, experienced an uncontained failure of the right engine. One cabin window separated from the fuselage after it was struck by debris flung from the exploding engine. The passenger sitting next to that window was forced through the opening and ejected from the aircraft. His body was found 2 years later. The crew initiated an emergency descent, and landed the aircraft safely. November 12, 1975, an ONA DC-10 ferry flight suffered a bird strike while on takeoff roll from Kennedy International Airport, New York. The aircraft was destroyed. All passengers survived. January 2, 1976, an ONA DC-10 experienced an undershoot on the short runway in Istanbul, Turkey. The aircraft touched the ground and crash-landed, then a fire in the number 1 engine started. The aircraft was destroyed. All passengers survived. October 31, 1979, Western Airlines Flight 2605, a DC-10-10, collided with construction equipment after landing on a closed runway at Mexico City International Airport, killing 72 of the 88 people on board and 1 person on the ground. November 11, 1979, an Aeromexico DC-10 entered a sustained stall while climbing through floor 300, over Luxembourg, Europe. The pilots failed to recognize the stall condition and instead blamed the heavy buffeting on the number 3 engine, which they shut down, while they continued to hold the nose up. The aircraft finally nosed down on its own and the pilots recovered before reaching floor 180, after they quit pulling back on the control column. The engine was restarted, the declaration of emergency cancelled and the flight continued to Miami, Florida. Ground inspection revealed 4 feet missing from each of the outboard elevator tips, including their balance weights. The NTSB found that the failure of the flight crew to monitor their flight instruments led to the sustained stall buffeting, which imposed structural overload, causing the failure of both outboard elevator tips and balance weights. November 28, 1979, Air New Zealand Flight 901, DC-10-30ZKNZP crashed into Mount Erebus on Ross Island, Antarctica during a sightseeing flight over the continent, killing all 257 on board. The accident was caused by the flight coordinates being altered without the flight crew's knowledge, combined with unique Antarctic weather conditions. January 23, 1982, World Airways Flight 30, a DC-10-30CF, registration N113WA, overran the runway at Boston Logan International Airport. All 12 crew survived, but 2 of the 200 passengers were never found. September 13, 1982, a Eurospantax Flight 995, DC-10-30 CFECDEG was destroyed by fire after an aborted takeoff at Malaga, Spain. 50 passengers were killed and 110 injured due to the flames. December 23, 1983, a Euro-Korean air cargo flight 084, DC-10-30 CF Hill 7339 was destroyed after colliding head-on with a Piper PA-31 Navajo while taxiing at Anchorage, Alaska. All on board both aircraft survived. July 27, 1989, a Euro-Korean Air Flight 803, DC-10-30, registration HL7328 crashed short of the runway in bad weather while trying to land at Tripoli, Libya. A total of 75 of the 199 on board plus another 4 people on the ground were killed in the accident. September 19, 1989, a Euro-UTA Flight 772, DC-10-30 N54629, crashed in Tar Copyright Na Copyright Ra Copyright Desert in Niger following an in-flight bomb explosion, claiming the lives of all 170 on board. December 21, 1992, a Euro-Martima Flight 495, DC-10-30 CFPHMBN crashed while landing in bad weather at Faro, Portugal, killing 56 passengers. April 7, 1994, FedEx Flight 705, DC-10-30 N306FE experienced an attempted hijacking. FedEx employee Auburn Calloway tried to hijack and crash the plane, but the crew fought him off and returned to Memphis. June 13, 1996, a Euro-Garuda Indonesia Flight 865, DC-10-30 PKG had just taken off from Fukuoka Airport, Japan when a high-pressure blade from engine number 3 separated. The aircraft was just a few feet above the runway and the pilot decided to abort the takeoff. Consequently, the DC-10 skidded off the runway and came to a halt 1,600 ft past it, losing one of its engines and its landing gear. The Air France Concorde crash of 2000 was attributed to a metal fragment that fell from the thrust reverser of a Continental Airlines DC-10 that had taken off 4 minutes earlier. This fragment was traced to third-party replacement parts not approved by the FAA. Specifications. Sources: DC-10 manufacturer data, airliners.net, and Flight International. Deliveries, see also. Related development, McDonnell Douglas KC-10 extender, McDonnell Douglas MD-11, aircraft of comparable role, configuration and era, Lockheed L-1011 TriStar, Airbus A300, Ilyushin Il-86, references, footnotes. Citations. Bibliography. External links, DC-10 page on Boeing.com, DC-10 history on Boeing.com, DC-10 and MD-10 page on airliners.net, DC-10.net website, early DC-10 concept.